In today's class, we are going to study about the image of a point with respect to a line, or in other words, we can also say that image of a point in a line. Now here we are given a line whose equation is written here, and a point is also given. The coordinates of the point are 1, 6, 3. Now viewers, here we want to find the image of this point P with respect to this line, and here we can take this line as a mirror, right? We can treat this line L as a mirror. Now we want to find the image of this point P with respect to this line. Now, so what we will do, if this line L acts as a mirror, then the image of this point P will lie in this side, and it will lie somewhere at this point. Say this point is Q, right? And suppose this point Q is alpha, beta and gamma. And always remember, when this line L is treated as a mirror, then the distance of this point P from this line is equal to the distance of this image from this line, right? Now let us join these 2 points with the help of a line, right? So we have obtained here a line PQ, and which is perpendicular to the given line L, right? Now the drs of this line PQ are see x2 minus x1. We know that the drs of a vector joining 2 points x1 y1 z1 and x2 y2 z2 are given by x2 minus x1, y2 minus y1, z2 minus z1. So therefore the drs are alpha minus 1, beta minus 6 and gamma minus 3. So these are the drs of PQ, right? Now we will make use of the fact that this point M is the midpoint of PQ, right? So therefore the coordinates of the point M are given by alpha plus 1 by 2, beta plus 6 by 2 and gamma plus 3 by 2, right? Here we have applied the midpoint formula, which says that if the 2 points x1 y1 z1 and x2 y2 z2 are joined by a line segment, then the midpoint has the coordinates x1 plus x2 by 2, y1 plus y2 by 2 and z1 plus z2 by 2, right? So here the coordinates of M are given by these points, right? Now let us find the coordinates of the general point on a line, and let us say that x by 1 equal to y minus 1 by 2 equal to z minus 2 by 3 is equal to lambda, right? So the general point lying on this line L is given by x by 1 is equal to lambda, y minus 1 by 2 is equal to lambda, and z minus 2 by 3 is equal to lambda, right? Okay. Now Here if we solve these three equations, we get x equal to lambda, y is equal to 2 lambda plus 1, and z is equal to 3 lambda plus 2, right? Now the general coordinates on this line L are given by lambda, 2 lambda plus 1 and 3 lambda plus 2, right? And from the midpoint formula we have also calculated the coordinates of the point M as alpha plus 1 by 2, beta plus 6 by 2 and gamma plus 3 by 2. So we will equate, because this general point may be M, right? So if we compare these two coordinates, we see that alpha plus 1 by 2 is equal to lambda, then beta plus 6 by 2 is equal to 2 lambda plus 1, and 3 lambda plus 2 or gamma plus 3 by 2 is equal to 3 lambda plus 2, right? Now we will solve these three equations, and we will solve these three equations. So we get from here alpha is equal to 2 lambda minus 1, and beta plus 6 is equal to 4 lambda plus 2, which implies beta is equal to 4 lambda minus 4, and from here gamma plus 3 is equal to 6 lambda plus 4, and this implies gamma is 6 lambda plus 1, right? So we have obtained the values of alpha, beta and gamma in terms of lambda, right? Therefore the drs of PQ, the drs of the line PQ are given by alpha minus 1. So here we have the value of alpha as 2 lambda minus 1. So we have 2 lambda minus 1, and then beta minus 6, the value of beta is 4 lambda minus 4 minus 6, and then we have gamma minus 3. So this is 6 lambda plus 1 minus 3. So if we simplify it, we get 2 lambda minus 2, this is 4 lambda minus 10, and this is 6 lambda minus 2, right? So these are the drs of this line PQ, right? Now the drs of the given line, are 1, 2 and 3. 1, 2 and 3. So here if we apply PQ perpendicular to the line L, and if two lines are perpendicular and if their drs are A1, B1, C1 and A2, B2, C2, then we have the condition for two perpendicular lines as A1, A2 plus B1, B2 plus C1, C2 is equal to 0. So here we have this is A1, B1, C1, this is A2, B2, C2. So therefore we have 2 lambda minus 2 times 1, 4 lambda minus 10 times 2, and 6 lambda minus 2 times 3 is equal to 0. So if we solve this equation in lambda, we have this equation 2 lambda minus 2, 8 lambda minus 20, then 18 lambda minus 6. Now this is 8 plus 2, 10, and 10 plus 18 is 28 lambda, and here we have minus 20, minus 2 and minus 6. This is minus 28. So we have 28 lambda is equal to 28, so lambda is 1, right? So therefore the value of the scalar lambda is 1. Hence the coordinates of the point Q, which is the image of point P, are given by alpha is given by 2 lambda minus 1, beta is given by 4 lambda minus 4, and gamma is given by 6 lambda plus 1. So if we substitute this value of lambda here, we get 2 times 1 minus 1. Here we have 4 times 1 minus 4, and here we have 6 times 1 plus 1. So this is 2 minus 1, this is 4 minus 4, and this is 6 plus 1. So this is 1, this is 0, and this is 7. So therefore the image, this image of this point P has coordinates equal to 1, 0 and 7, right?